Water. It's found everywhere on Earth, from the polar ice caps to steamy geysers. And wherever water flows on this planet, you can be sure to find life. When we find water here on Earth, whether it be ice-covered lakes, whether it be deep-sea hydrothermal vents, whether it be arid deserts, if there's any water, we've found microbes that have found a way to make a living there, said Brian Glazer, an oceanographer at the University of Hawaii at Manoa, who has studied astrobiology. That's why NASA's motto in the hunt for extraterrestrial life has been "Follow the water." Yesterday, September 28, NASA scientists announced they'd found it on Mars. Dark streaks that scientists have spotted seasonally for more than a decade in images of the red planet are evidence of flowing water, new research suggests. While the briny flows may be too full of chlorine-based salts to support life, they do raise the odds that Mars could have life right now, the researchers said. But just why is water such a crucial molecule for life? And could there be other ingredients that also provide the perfect recipe for life on other planets? It turns out that several chemical properties of water make it indispensable for living creatures. Not only can water dissolve nearly anything, but it is also one of only a few materials that can exist as solid, liquid and gas within a relatively narrow range of temperatures. At heart, all life on Earth uses a membrane that separates the organism from its environment. To stay alive, the organism takes in important materials for making energy while shuttling out toxic substances such as waste products. Because it flows, water provides an efficient way to transfer substances from a cell to the cell's environment. By contrast, deriving energy from a solid is a much tougher prospect, though there are microbes that eat rock, Glazer said. But the other part of the equation, that water can carry things into and out of the cell, has to do with water's unique chemical configuration. The humble water molecule is made up of two hydrogen atoms bonded to an oxygen atom. The way they're bonded together makes water this wonderful universal solvent, meaning that almost every substance can dissolve in water, Glazer told Live Science. That's because the molecule has polarity, meaning the hydrogen atoms tend to bunch on one side of the molecule, creating a positive region, while the oxygen end has a negative charge. The positive hydrogen end tends to attract negative ions, or atoms with an extra electron in the outer shell, while the negative region lures in positive ions, which have had one of their electrons stripped off. Water, with its amazing dissolving properties, is the perfect medium for transmitting substances, such as phosphates or calcium ions, into and out of a cell. Another feature of water is that it can act as a solid, liquid and gas within the range of temperatures that occur on Earth. Other molecules that have been identified as good candidates for supporting life tend to be liquid at temperatures or pressures that would be inhospitable for most known life forms, Glaser said. Water really is at that sweet spot, Glaser said. The fact that water can be in all three phases in a relatively tight range of pressures creates many opportunities for life to flourish, he added. All three states of water available on our planet creates this really neat variety of habitats and microclimates, Glaser said. For instance, frozen ice can be found in glaciers that carve through mountains, whereas water vapor helps warm the atmosphere, Glaser said. Water may be more than a fluid to help facilitate life's essential processes, it may also have been the protective cradle that carried the building blocks of life to Earth, said Ralph Kaiser, a physical experimental chemist at the University of Hawaii at Manoa, who has research experience in astrochemistry. One theory for how life on Earth emerged, called Panspermia, posits that icy comets smashed into Earth, bearing tiny organic molecules that formed the precursors to life. However, in its solid form, water could have provided a way to shield those molecules from radiation, Kaiser speculated. One possibility is that, because the building blocks are frozen within the water, it has this protective mantle around it that could be delivered, Kaiser told Live Science. Of course, while water is crucial to life on our home planet, there could be life forms that don't conform to the Earthling playbook. Scientists are also looking at other liquids that could play a similar role as universal solvent and transport medium. Some of the top contenders are ammonia and methane, said Chris McKay, an astrobiologist at the NASA Ames Research Center in Moffett Field, California. Ammonia, like water, is a polar molecule that is relatively abundant in the universe, but scientists haven't found any large bodies of ammonia anywhere in the solar system, McKay said. Methane isn't polar, but it can dissolve many other substances. Unlike water, however, methane becomes liquid only at very cold temperatures, at a frigid -296 degrees Fahrenheit, -182 degrees Celsius. We know that there are large lakes of liquid methane and ethane on Titan, one of the moons of Saturn, McKay told Live Science in an email. Thus there is keen interest is the question of whether life can use liquid methane-ethane.